Yeah, when they snap.
Why is this stuff on my computer?
When they snap those
Rip stuff, Kyle?
That's actually code from my team.
I
God,
have never felt like
Here, I got a clean one if you want it.
I'm good.
You see it all.
All right. So, as you prepare for the test tomorrow, keep in mind it's 20% of your grade. It's going to be all multiple choice. You don't have to show your work, but you can have scratch paper. Okay? So
there's no points for work?
no, it's either right or it's wrong.
That's the way I love my tests.
So, which is both good and bad.
I don't know.
Mostly bad.
Those have credit.
Which is both good and bad, like I said yesterday. So let me give you an example of how I'm going to be a jerk when I write this test. Okay?
You're gonna give every single possible wrong way of doing it as an
Exactly.
option.
So I'm going to say, here's a rocket. Okay? And I'm going to tell you that it has an upward force of 40 newtons and it has a mass of 2 kilograms. And I want to know what the acceleration is going to be.
Are you gonna have like the same number, like the same value, but like positive and negative signs too?
No, I'm not.
You're not gonna be that big of a
I'm really not. No.
That's like the worst.
So here's the deal. So what are you going to do wrong on this problem? You're going to take 40 newtons and you're going to divide it by 2 kilograms, and you're going to say, oh, the acceleration is 20 meters per second squared. Okay? And guess what? That will be an option. Okay? I am.
Is this a Scantron or is it like a packet?
No, it's going to be, what's going to happen is that you're going to have a packet that you can write on, the test question, then you're going to have an answer sheet where you're going to write your answers.
Okay.
You don't, I hate Scantron. So I actually I always have to go back and replay it anyway, even if it's Scantron. I haven't done Scantron probably 10, 15 years.
Alright.
So,
Well, maybe they upgraded their,
I was
like,
gonna say, they probably made quite a few advancements.
no, because I still have to go through, because like if you erase it, and then it isn't fully erased, and you answer it right, it counts it wrong, and then I gotta go back and look at it anyway, and it's just annoying. So I just do the sheet. Okay. Now, why do I knock that over?
probably because you do that every day. That does not need to be required.
For every action.
No, Jim's doing that.
Yeah, I know. So I'm not the one that ever.
Okay. Now, in which situation would 20 meters per second squared be the correct answer? There's two situations where that would be the correct answer.
Deep space.
If you're in deep space, or,
If you're matching.
Or it's actually accelerating at 20.
no. Or if you launch it horizontally. Okay, if I launch this rocket horizontally, gravity would not act as an opposing force. Okay? Now, is acceleration a vector quantity?
Yep.
Yeah.
Yes. Okay? So, here's a thing that you can do. This is the person preferencing. Here's another option that you can do. You could sit here and go, okay, I am going to have an acceleration of 20 meters per second squared if there is no gravity, right? So that would be my acceleration if there is no gravity. Now, acceleration due to gravity is going to point which way?
Downward.
Down. And it's going to have a value of what?
Negative 9.80 meters per second squared.
Okay? That's going to be negative 9.8 meters per second squared. So the difference between those two is what?
10.2.
Okay? Meters per second squared. Now, let's go through the whole idea of net forces. The 40 newtons is fat, fop, or finette. Fat, that's my applied force. My opposing force is going to be
Acceleration due to gravity.
negative 19.6 newtons. So that gives me a net force of
20.4.
20.4 newtons, right? If I divide that by 2 kilograms, I get
10.2.
meters per second squared, which is the exact same answer that you get there.
So that's the
2 times 9.
Oh.
Yeah. So here's my fat, here's my fop, there's my finette. Divide that, I get 10.2, or you can say, here's my acceleration, which is a vector quantity. I have an opposing acceleration of negative 9.8, I get 10.2. Okay? So either way, you end up with the same answer. If you look at it in terms of forces, or if you look at it in terms of accelerations. Okay. Precision and accuracy. Can you always talk about the precision of a measurement?
Yep.
Yes, because that's based upon what?
Significant.
How good your ruler is.
Well, basically how many divisions there are on the ruler or the measuring device, whatever that is. Okay? So you can always, always, always talk about precision. What do you have to talk about accuracy, Ms. Treadway?
You have to have like a universal thing for it.
Yeah, an accepted value.
Yeah.
Okay, you have to be able to compare it to a number. So like when you all did, back when you bounced the golf ball and it went up and it came back down, and you found an experimental value for gravitational field inside this room, okay? You can compare that to an accepted value of 9.8, okay? So, boom, there you go. All right.
I'm done now.
What else can we talk about? Independent, dependent variables. Which goes where?
Independent on the X, dependent on the Y.
Independent variable is on the x-axis, dependent variable is on the y-axis. Okay? So, I know we're going old school, way.
Independence on the X, right?
Yes. Okay, like if you have force and acceleration. Hallie, if I'm dealing with force and acceleration, which one do I control? So that's going to be my independent or dependent? Independent, so that's going to get graphed on the beautiful. My acceleration is going to be then graphed on the y-axis. So if you look at, for example, where you have a setup like this, where you've got a cart, and you've got a mass hanging off the end. Okay? Sorry, I promise you, you're going to have something like this.
I'm glad these concepts.
Actually, I wasn't going to, but now that I know that you hate them, I'm going to put them on.
Well, you know, I love, actually, I hate independent, dependent. I hate
Precision
precision,
and accuracy.
stuff like that really gets me.
I don't care. Okay. So, here's the deal. What's the only force available to accelerate the system?
Gravity.
Acting on?
The
Mass.
The fat.
So, this is always going to be your fact. Okay? True or false? You have the 50-50 shot. True or false? The weight here, the force here, has to be greater than the weight of this cart to make it accelerate.
False. Great, you were. This Treadstone
False?
is sounding pretty scared.
Well, remember back when we took that tiny little 10-gram mass and we had like that 500-gram mass sitting up here, right? Yeah, it doesn't have to be greater than that, okay? But if I go from 10 to 20, I'm increasing the force, right?
By 2.
Doubling the force. Now, if I keep the mass constant, if I double the force, what should happen to my acceleration? It should double because it's just a linear relationship. Okay?
So you could have like, so what if you have like 5 grams trying to pull 1,000 grams?
If it's a frictionless surface,
Okay.
Yeah.
it will do.
But what if it's not? How do you calculate that again?
Then it probably won't if there's any friction at all. If you got
Yeah,
5
but how do you calculate it to be sure?
Well, you have to
You do 1,000 times.
You'd have to figure out what your opposing frictional force is up here. If your frictional force up here is greater than that force, it won't move. Okay. Now, let's see if we can follow that thought process all the way through.
2 years ago.
Try to find the acceleration. Use the total mass of the whole system when we try to find the acceleration.
Okay, that's what I was doing.
Okay. So let's say that I've got,
Can you just lightly set one?
yeah, Okay.
You're gonna slam it.
No, I'm not. No, I'm not. No, I'm not.
See what I did there? I said the opposite thing, so then you were just gently.
Reverse engineering.
Okay.
Give me
It's reverse psychology.
Okay. That's like rocket.
Okay. So let's say that I have, it sounds like a really bad band, Hank and the golf ball. Okay? And I'm going to drop them both at the same time, which I'm not going to. Okay?
That would break.
Poorly for any number of reasons. Okay? But if I drop them both at the same time, will they accelerate at the same rate? Yes. But why do they accelerate at the same rate? Is gravity the same for both of them?
No.
No. Bad. No. Let's say that Hank has a mass of, I don't know, 10 kilograms, and the golf ball has a mass of 0.1 kilograms. So, how much force is acting on the 10 kilogram mass?
98.
10 times 9.8, right? So I've got a 98 Newton force acting on here. How much force is acting on the golf ball?
0.98.
0.9.
Right? So is the same amount of gravitational force acting on both? No, it's not. I don't have the same force acting on both. But do I end up with the same acceleration?
Yes.
Yes, because look at this. If you look at F equals ma, so your acceleration is force divided by mass. Mara, I want you to pay attention to this. If you divide force by mass, you get acceleration. Okay? All right. So, in both situations, I end up with the same acceleration of 9.8 meters per second squared. So what happens with Hank is that I've got a big force, but it's acting on a large mass. On the golf ball, I've got a
Small
force acting on a,
small mass.
and I get the
Small.
same acceleration. Okay? Good with that. Okay. Now, what's Newton's third law? Every force there is equal to opposite force. So visualize this. I've got an elevator that's accelerating upward. Okay? It's accelerating upward. It's accelerating upward. Okay? And in here, I've got a box that I'm just going to call 2m. And on top of that, I've got a box that is just mass, smaller mass. Okay?
Is 2m twice as much as mass? Is
Yeah.
that what that means?
Yeah.
All right, I was just clarifying.
Yeah.
Those.
Yeah.
Yeah. Well, that was.
Now,
No depth of field.
when this thing accelerates upward, does the 2m box exert a force on the m box? Okay. So visualize this elevator. Okay?
I hate the elevator.
It's accelerating upward.
Okay? This whole thing is accelerating upward. So here's my question. Does the 2m box exert a force on the m box?
Yeah.
Yeah. Because if it didn't, what would the m box do?
Fall.
Yeah, it wouldn't accelerate. Okay? So the 2m box has to exert a force on the m box. Okay? Now, does the m box exert a force on the 2m box?
Yes.
Yes.
Yes. Which is the greater force? The 2m box on the m box or the m box on the 2m box?
Aren't they
Or are they the same?
They're
Are they
equal.
equal?
Because neither one of them.
Because of,
Newton's, 1 Newton's law.
how about the third?
The third.
Okay? So the 2M box has to exert an upward force on the M box. But by Newton's third law, the M box has to exert an equal and opposite force on the 2M box. Okay? Now, if it takes, and you're going to hate this, but let's just talk about this. If it takes force F to move the elevator at a constant velocity, okay, now I'm talking about the entire elevator. It takes force F to move the elevator at a constant velocity. When it's accelerating upward, is the force to accelerate it upward bigger or smaller than F? Or is it the same size?
Possible.
No, now I'm accelerating it upward. F is at constant velocity. F is at constant velocity. So to accelerate it upward, is F going to be bigger or smaller or equal to F? Bigger. Why? Yeah, so not only do you have to provide the force to overcome gravity, you have to add in the additional force to make it accelerate. Okay? So if I accelerate upward, it's going to require more force. Think about this. If you're going to lift a weight off the ground and it weighs 100 pounds, you have to exert probably at least 101 pounds of upward force. Okay? Now, let's say the elevator, now stay with me here. The elevator is moving downward, okay? But it's going to slow down as it goes down, okay? So visualize this. Because if you've ever ridden an elevator, right, and you're going from the 10th floor down to the 1st floor. At some point, you have to slow down, right? So in the process of slowing down, is the upward force here going to be bigger or smaller than the downward pull of gravity?
Smaller.
Smaller.
Yep.
Everybody cool with smaller? How many vote smaller? We are all going to die.
Cool with that.
Okay, now think
Oh,
about
yeah,
this.
we would die, wouldn't we?
We would die, because now you all are going to make this thing speed
Because
up.
then we're going to just fall.
You said you're just slowing down.
I am, you're right. Okay, now look at this. Look at a velocity time graph. Here's 0 meters per second, right? You're moving down, so you have some negative velocity. True? You have some negative velocity. What do you want this velocity to do as you approach the ground floor? You want it to go to 0. I don't want it going down like this. This is bad. Okay? I want this velocity time graph to move up towards 0. So if it's moving up towards 0, what's the sign of my acceleration? Positive. I have to have a positive acceleration. What's the only way that I can create a positive acceleration in terms of sign of my net force? I have to have a positive net force, right? Well, if I've got some negative opposing force, then my upward force has to be greater than this so that I create a positive net force so that this thing slows down and goes towards 0. So if I'm going to slow it down, and if you think about this, if you've ever tried to lower at weight, okay, so like if I drop Hank, okay, and then I catch him, well, if I'm going to make him slow down as he's falling, the upward force that I exert has to be bigger than the downward force. Because if my downward force, okay, if my upward force is less than that, what's it going to do? Yeah, then it's going to keep speeding up and bad things are going to happen. Okay? Now, if you're at 0 and you want it to accelerate upward, my applied force has to be bigger than my downward force. Okay? So, keep grand things in mind. Speaking of velocity time graphs, true or false? True or false? Brooklyn, true or false? My velocity time graph, the slope of my velocity time graph changes sign.
False.
The slope of my velocity time graph changes sign. Do I change direction? Not necessarily. Okay. So if I've got a velocity time graph, here's 0 meters per second, right? And I've got some action like this going. Did I ever change direction? No. Why, Brooklyn? Yeah, I didn't cross it at 0 meters per second. Now, if I do this, okay. Did my net force change sign? Me. Did my net force change sign from here to here? No. You want to stick with that answer?
No.
No. Don't.
Nah.
You said yes.
Okay.
I said yes earlier, but you just stared at me.
Oh, I didn't hear the yes. Oh, my bad. Let the record clear the show. I did not hear the first response of yes.
I was like, why are we staring so blankly?
I didn't hear him say anything.
Bergkamp had the Kendra moment today.
That's an insult. That's an insult.
Oh,
Someone
at some
is
point,
failing.
the Kendra moment is going to be written into the text. And it will say, someone's having a Kendra moment.
Oh
and
God.
says, that is going to be on the text.
Oh
Mark
no.
Okay.
What's the correct answer?
So,
You stared at me.
it does, my net force does change sign. Why does my net force change sign?
Because you're slowing down when the slope changes.
You're right, but let's jazz it up a little bit.
Okay.
Okay? Net force equals what?
Mass times acceleration.
Mass times acceleration. The slope of a velocity time graph is u.
Acceleration.
So if I go from positive acceleration to negative acceleration, my net force has to change sign. Can I change direction without changing the net force? Can I change direction without changing the net force? Lexi, you shake your head yes. Why?
Because if it's just a straight sloping line down, then you never change your acceleration.
Beautiful. So if I have a velocity time graph that looks like this, so like if I throw this ball up in the air and look at it from the point that that leaves my hand, I have the same net force the entire time. I change direction.
Wow. That's pretty cool. That was a good one. That kind of just blew my mind.
Okay. Inclinatio ad quitum.
I didn't.
Stop.
Stop the force and watch.
Wow.
Okay. Now, speaking of inclinatio ad quitum, I push the box and it comes to rest. Inclinatio ad quitum.
Simple.
But why does it come to rest? Because there's friction. If there was no friction,
Continue.
it would just keep going because it has
No opposing.
no opposing force, but it has mass and it has inertia. What's the only thing that affects inertia?
Mass.
Mass. Okay?
Charts is on a roll.
Okay? So as long as the mass doesn't change, the inertia doesn't change whether it's at rest or not. What are the two types of friction? Two. Static and kinetic. Okay? Kinetic is from the Greek word meaning kinesis, meaning in motion.
Yes, sir, it is.
Okay.
Yes, that is correct.
Thanks. Appreciate that. Okay. There will be inclined plane problems. Okay?
Those are okay.
Those are okay. Now, what are you going to do wrong when you do force friction on an inclined plane?
Wrong. It's good.
I'm gonna draw my triangle.
You're going to draw your triangle, which this is going to be
FG,
FG,
And then F
F
parallel.
parallel,
force parallel,
then up is force normal.
up like
And,
this.
At a 90-degree angle from the plane.
Wow.
You asked us what we're gonna do wrong. We're not
We're not
gonna
gonna make any
These
mistakes.
ones are.
Okay, I'm gonna tell you what you're gonna do wrong. You all sit here and go, Mr. Burkamp, we won't do that. You lie.
Oh, when you're sliding it
Talk
up,
about how.
the frictional force goes down.
Okay, well, but hold on.
Depends on.
Why would you?
Okay, when you look at mu equaling force friction over force normal, what are you going to do wrong with that force normal?
But you're gonna do sine instead of cosine.
No,
You're gonna use force gravity opposite.
yes, you're just gonna set this as the same as your FG.
Oh, but
Who would do that?
I would do that.
Come on, guys. You're better than this. You're better than
So
this.
that's gotta be FG cosine
Alright, so
theta,
we're going down.
alright?
Let's do that.
Okay. There will be projectile motion problems, limiting problems and ground to ground, okay? I promise you there's gonna be a problem that's all gonna get worked into one big problem, where you shoot something off the top of a bridge and it falls like this as a projectile motion problem, and you gotta figure out how far from the base it lands, maximum height, all that good stuff. I promise you, this is going to be there, okay?
Good. That's what's in our most recent brain history.
Yeah.
Our
This
most
is this.
recent-
That doesn't make me any better.
Brain.
Yeah, it really doesn't.
Alright,
Just
I have the most
most
recent brain history.
I
I have a question.
Okay.
Why would we
Everyone
die
gets in.
if, can we go back to that?
Are there gonna be
question?
free body diagrams? Yes. Are there gonna be any?
I will not make you draw any.
Oh,
But we do have to know how to draw them to pick the right answer, or they're not gonna be on the list.
Maybe.
You have to be, like, for example, to do this,
Okay, yeah.
I won't explicitly make you draw them, but
Okay.
if you draw them, it makes life simpler,
Yeah.
okay?
About the other.
And when you get into complex problems, set up a chart and go, okay, hey, what do I have going? You know, on any problem, what are your only two options for your net force? What?
Positive and negative.
No, well, no, broader idea. Positive.
Well, that's two of the options.
I mean,
Technically rational.
technically
Wouldn't
that's
it
not
be,
wrong.
it's either gonna equal to zero or it's not?
Yeah, it's either equal to zero and you're a constant velocity, or it doesn't equal to zero, when it could be positive or negative.
Yeah, actually, there are three options. It could be zero, which is not.
Yeah. Yeah, zero, positive, negative.
It's neutral.
Okay. Okay,
You're right.
so every problem, this is gonna be one of two things. It's either gonna be zero or
No.
a positive or negative number. So make a list of everything that could possibly be acting on the system. Okay? Now, same idea. I'm going to throw this golf ball up in the air. To make this thing accelerate upward, my applied force on my hand has to be greater than the downward force. So, but as soon as it leaves my hand, what happens to my applied force?
Because
Gone.
It's gone. Now, as soon as it leaves my hand, let's talk about, this is a question on that force test that you all just took. As soon as it leaves my hand, is there an upward force that drives it to keep going up that is opposed by a downward force of gravity? No. But why does it want to keep going up?
Because it has.
Because objects in
Motion.
motion want to maintain a constant speed. So, if I throw it up, remember, inertia is not a force. Inertia is a tendency to maintain a state of motion. Okay? So when it leaves my hand, if there was no gravity, what would it do? Yeah, it would just keep going up. So when it leaves my hand, there is no force pushing it up. Just like when I let go of that box of paper clips, is there, as soon as it leaves my hand, is there a force that keeps it going in that direction? No. Okay? It isn't there. But there is an opposing force of friction that makes it slow down. Inertia wants to keep it moving. Okay? All right. So those are the big ideas. So what I've got beyond that list of topics that are on the test. So as always, here is the review.
oh, thank you.
Okay?
For a second, it's getting late.
And there's two of them, the blanks. and the answer keys. Okay? Again, don't breathe on this. Okay, so I am done. You have the rest of the time. I also have your old tests. You can't take the test with you, but if you want to look at your old test during this time, you can. And invariably, here's what happens, especially you go back to that very first test, like on the math toolkit, and you look at that and you go, oh my God, I can't believe I missed those questions. It always
We were
happens.
coming off
So-
summer.
Huh?
We were coming off summer.
What about
I
now?
didn't remember. Why? It wasn't so bad on the first test.
Jake.
Don't talk.
Jake.
I feel like you're good.